Okay, I think that's it then. Well, let's thank the speaker, and then we'll move on to the next talk.
Right, thank you.
I believe the next talk has been recorded ahead of time, so we're going to play the talk, and then we'll have questions at the end.
My name is Meng. You may know me on Twitter as Meng Wong. Over the past couple of years in Singapore, I have had the privilege of studying computational law in the company of Dr. Martin Strecker, Avishkar Mahajan, Inari Listenma, and other colleagues, including Jason Morris, who presented earlier. So when people ask, what's interesting about comp law? I usually say something like static analysis and formal verification. And they say, what? And I say, using computers to find loopholes in the law and mistakes in contracts. And then they say, well, that sounds like magic. And I say, yes, in fact, it's the kind of magic the Avengers used to beat Thanos. Remember this? He's actually talking about model checking with CTL. So I'm going to talk about how we found a race condition in the law, thanks to Dr. Seuss here. And then I'll talk about other things our platform tries to do, and I'll finish with a tour of the syntax and the IDE. So this is the law where we found the race condition. Singapore's GDPR is the PDPA. Hypothetically, if your computer's got pwned in a data breach and exposed user information, the law says you have to tell the users. So, not so hypothetical, a few years ago, Singapore managed to lose the medical records of about a quarter of the population. And we know this won't be the last time that happens. So to improve the user experience for whatever tech company next gets pwned, the Personal Data Protection Commission is now working with us to streamline the creation of applications like this one to help you work through the aftermath of the next data breach. The law says if you think you got pwned, you have to investigate. You have to assess, is it a notifiable data breach? And if it is, you have to tell the government as soon as possible, ASAP, 3 days. You also have to tell the affected users that you lost their data, with some exceptions. And at this point, people tend to be very interested in exceptions. And this is what we call the planning problem, abductive reasoning in law. There's an obligation coming up that I want to get out of. What do I need to do? To explore the exceptions, we can use a SAT solver, Prolog, SCASP, Klingo to do abductive reasoning. And in our system, we export to ASP and we get some answers back. Anyway, if none of the exceptions apply, then you have to notify the users ASAP in parallel with notifying the commission. But maybe the data breach is so sensitive that the PDPC tells you, hold on, don't notify the users just yet. We need to manage the PR story. Oops, too late. I already told the users because I did everything ASAP. So that's a race condition, and to find it, we export to a model checker called UPAL. We write a CTL property that says, did I inform anybody I was not supposed to? And the system comes back with a trace showing how this race condition could arise. And in our language, all this turns basically into a compiler warning for the developer to think about. I should say I'm not claiming originality here. The idea of model checking contracts goes back to some work that was done in Scandinavia 15 years ago. And this paper introduced the idea of tax evasion as a problem in abductive planning. So we just want to bring all these capabilities together in one place and give legal drafters the kind of feedback that programmers usually get from a compiler. You know, in law, it's better to find bugs at compile time because exception handling at runtime, that's called litigation. Now, to be fair to the government, this is a pretty trivial toy example. Their guidelines already do talk about this particular situation. They did anticipate it and they do address it. But you can imagine more complicated situations that are harder to anticipate where having a robo-lawyer starts to really make sense. Because model checkers today are capable of handling incredibly large state spaces. They can explore every possible feature under the contract and find those edge cases. 14,605 features. But this magic wouldn't be very magical if it needed humans to do a lot of the work, right? Our job as computer people is to help streamline and automate everything we can. So let me talk about the downstream applications and transpilation targets that would benefit from this. A to J, access to justice applications, help end users make sense of legal situations. In rules as code situations, we want to give the people drafting laws error messages when we find these loopholes or monotonicity violations or inconsistencies like the race condition that we just saw. And as a flex, we want to output to different natural languages and summarize the semantics in different ways. So following the example set by GHC, we currently have a core language with a rigorous semantics and a more user-friendly language, high in sugar, syntactic sugar, that translates down to the core. And from that, we transpile further to different applications and backends. And in future, as we develop confidence in the semantics of the higher level sugary language, we may just transpile to the applications directly. So let's talk applications. The simplest one I like to call Delora the Lore Explorer, because nowadays regulations come at you so fast, who has time to hand build a website or even an infographic? We need a law explorer. And that was the first thing the PDPC asked us for. So we made a simple app builder that automatically generates a web UI out of the encoded rules. I used to call this an expert system. And it does pretty much what you would expect. The system does the usual deductive reasoning and offers its answer, plus an explanation of how it arrived at that answer. And speaking of explanations, I want to give a shout out to the SCAS people for their commitment to readable justifications. This turns out to be an important differentiator vis-a-vis statistical machine learning, because GPT-3 can write a poem, but it can't explain a regression equation. So for anyone out there writing grant proposals, remember the magic word is explainable AI. Now, if you're a computer scientist, you may think that printing out the traversal of a decision tree is too trivial to be interesting, but explanations are important for industry, because after you click through the web app, you want to be able to generate an explanation that you can copy and paste into the report that you send to management, and that is business value right there. And for extra business value, you can add an infographic. This is d3.js at work, and this also goes into the report to management. And if you want to push L4 into, not just a management report, but to some kind of enterprise software decision support system, like maybe Drools, we can do that. And we've also looked at BPMN and DMN for the UML people out there, business rules management systems. And that is how we turn constitutive and prescriptive rules into useful applications. Does everybody know what I mean when I say constitutive and prescriptive rules? I got that from Legal Rule ML. Constitutive rules are basically A counts as B if C holds. And Prolog is good at this. Prolog is what you would use to encode the British Nationality Act as a logic program. Hello, Professor Kowalski and people from Logical English. So if constitutive rules are the data structures, then prescriptive rules are the control structures. We model them as a collection of timed automata over multiple parties. Do you remember the contract as automaton paper? It turns a contract into GraphViz, basically. The green stuff is the happy path. Everything else is reparation pathways for when things don't go as planned. And if you added time to the edges of this DFA, you would get a timed automaton, which you can push into a model checker, UPAL. We can also export to a PetriNet, which is like a more formal version of a flowchart, and we can model check that as well. One last output target, last but not least, natural language text, because it starts in text. And if we could round trip back to natural language that was word for word identical to the original legislation, that would be a really nice way to validate the system. So if you can compile to one language, you could cross-compile to more, right? Spanish, French, German, Chinese. You could imagine this being useful in Quebec or in the EU or in Asia, where people need multilingual contracts and multilingual laws. But we don't do this with machine learning. We want to use a tool called GF. GF is much more precise, and it's the right tool for this particular job. So these are some of the targets for the language, but none of this matters if the language doesn't get traction. And traction is up to, I think, the syntax and the developer experience. Now, we don't have time to go into the precise logical semantics of the language, so I'll just show the syntax and talk about the approach. Legal Rule ML says there are two types of rules, so we have two types of rules. Prescriptive rules look like this. get a key value pair for a party, a deontic over an action, a temporal constraint, and a predicate condition. Right? There are other keywords, but this is the essence of a prescriptive or regulative rule. Every person may park for free until midnight when it is an off-peak day. When is it an off-peak day? It is an off-peak day if it is a weekend or it is a public holiday. And if you check these boxes, the logic works and you get the results. Now, we are very grateful to the people behind Legal Rule ML because it is their shoulders we stand on, and on the shoulders of the Copenhagen group, who about 10 years ago not only formalized a contract specification language, but also implemented it in Haskell. Some of that work is now turning into a startup. And in addition to these two primary influences, we do hope to learn from all the work by all the people who are with us today and all the people who are not with us today. So that's the concrete syntax. But what exactly is different from what has come before? Where is the novel contribution? Leaving aside all the technical issues of logic and semantics, we worry about the adoption challenge. The person sitting at the keyboard is never in a million years going to install VS Code or Emacs or Vim or anything like that. So I don't think it's unfair to say that their comfort zone starts at Microsoft Word and it ends at Microsoft Excel. So fine, Excel it is. This stuff is actually in Google Sheets. The link is in the slides. This is the IDE. For power users, we want to always keep the plain text VS Code option available. But before we have power users, first we need any users at all. So if you download this as a CSV, the L4 looks like this, literally comma separated values. And let me just say to the compiler people in the audience, when your input is a CSV, you get to outsource your lexing and your tokenization, which is pretty awesome. And you get layout indentation for free. Push it through the parser, and you get an AST. And from the AST, you can transpile to all the targets we just talked about. All this code is on GitHub, by the way, but it is very early. And if you want luxuries like a makefile or a tutorial, please give us another 6 months. Some of the functionality I'm presenting is still a work in progress, but even if it doesn't work 100%, I promise it is in development and it is on its way there. So spreadsheets also make unit testing easy. Given these inputs running this rule, you should expect this output. And it's close enough to natural language that people should be able to just do this without too much training. Right now, our language reference is a single tab in the spreadsheet, so I'm not going to go into the details. But I will just say that our approach to choosing these keywords was to look at existing legal text, identify the relevant logics at work, paint the text with the appropriate types, basically, rearrange it according to the logic, and you get a sentence that makes sense to humans but has enough logic for a machine to process. Speaking of logic, I like to joke that contract languages have enough calculi to form our own LAMP stack. Lambda, mu, and pi. LAMP. So we have a syntax that's deliberately similar to existing legal writing. Here we see 3 clauses, 1, 2, 3, nested, and connected by hence and lest keywords. Keywords on the left, values go on the right, so JavaScript people should say, okay, not too different from JSON. And people coming from more of a legal background might find the sentence structure familiar. It took us maybe a day or two to turn the existing legislation into this format. And in the course of doing all this, we encountered an interesting theoretical question. You can explicitly put a must or a may into an individual node in a state diagram, or you could look at the entire graph and consider the deontics to be an emergent property. It turns out that, if not doing something leads to breach, then yes, it's true that the party must do it. But that comes out of the CTL analysis and doesn't have to be said in the source itself. So are deontics really a high-level graph level emergent property, or is it something we should put into the nodes? So we've been thinking about questions like this. We've been climbing the same learning curve that many other researchers have climbed. In fact, the next speaker is way ahead of us. He's already climbed this particular curve, and I really want to hear from him about model checking and proofs for laws in his language. And since I'm out of time, I will just finish by saying that we are open to collaboration. If our language is compatible with yours, please get in touch. We also have postdoc positions open in Singapore as well, so if you know anyone who's interested in this stuff, please send them to us. All these slides are available at that QR code, and the recording will be available from there as well. Thank you all very much. It's been great.
Okay, Meng, can you clarify that you can hear me? And that we can hear you?
Yeah, I think we are up. Okay, can you hear me? I think you're good. We have one question, right? So,
Meng, can you hear us?
yeah, I can hear you.
We are not. Oh, there we go. Okay, so we have a question in AirMeet. Can you go over examples of the key semantic rules governing the behavior of L4?
Yeah, can I share screen? My share screen is turned off. Cannot present while a question is shown on stage. Yeah, so the semantics, so I'll just answer that. So the semantics, there's nothing really original in terms of the semantics of the language. We're trying to make it easy for people to do basically two things. One, represent the state transitions of the deontics. So if A has to do something, then B has to do something, and C has to do something, we want to give a very clear syntax for saying that. And the second thing we want to make it easy for people to do is basically write Prolog. So this is maybe the third presentation that tries to do Prolog in English. We're doing it in a spreadsheet, but we want people to be able to do horn-like clauses that feel natural, but also parse very cleanly.
Okay, any other questions?
I see John has more of a comment than a question. He likes the idea of doing a spreadsheet. You know, people keep talking about spreadsheets for law, right? And some of the, like Michael Genezareth's paper on comp law talks about how there needs to be spreadsheets for law. So we thought, you know, why not actually just do spreadsheets for law? Let's do law in spreadsheets. So all of this is experimental. It's unknown how well people will take to this. But you know, one theme of today's workshop has been, how do we get people to actually use this? Can we converge on a sort of common baseline that is amenable to multiple backends, multiple semantics even? And this approach, you know, if we write the parser, then you don't have to, right? All you have to do is do the backend output to whatever you want to do.
Okay, thank